Okay, I am so sorry, my phone ran out of storage, so I'm just using another device to begin where I just left off. So for our x and y components of A, we have them written down here. And then we just found our x and y components for R, which is the total vector displacement with A and vectors A and P. So we know that the vector P is equal to the component the R vectors minus vector A. So what we can do to find the x and y components for vector P, we can do the x components of vector P is equal to the x components of vector R minus the x components of vector A. And then we'll do the same for the y components. Y components of vector P is equal to the y components of vector R minus the y components of vector A. So this will allow us to find our components necessary for our x and y components for P, which will allow us to find the magnitude of P. So now we're just going to go ahead and substitute in our values. So we got that the x component for R is minus 22.87, and then we're going to subtract that number from our x component for A, which was 38.366, and then we're just going to use our calculator. And that is equal to negative 61.53 meters. And then for our y components, we have 30.35 meters. That's our y component for R. And then minus our y component for A, which we got as 61.35 meters. And use our calculator again. And we get negative 31 as our component for y. So for our x component for the vector P, we have negative 61.53 meters. And for our y component for vector P, we get negative 31 meters. So we're going to use these two components to go ahead and we're going to go ahead and use these two components to go ahead and help us find the magnitude of P. And the way we do that is with the Pythagorean theorem. So we're just going to go ahead and put that in for here. The magnitude of P is equal to the square root of the x component squared plus the y component of P squared. Plug in our values, and then we get negative 61.53 squared plus negative, well, it'd actually be so you add it, negative 31 squared, and continue solving that. 61.53 to the power of 2 get 3,785.94, and then negative 31 to the power of 2 is equal to 961. So then 3,785.94 plus 961 is equal to 4,746.94. And then we just need the square root of that number, which is equal to 68.9 and then meters. So we can put that the magnitude of vector P is 68.9 meters. So here, I just set up the Pythagorean theorem, substituted in our values, and then used the calculator to help us solve it. And that left us with 68.9 meters. And that is the answer to that part of the problem. Part L asks us to then find the direction of vector P in terms of an angle measured counterclockwise from the positive x-axis. So, as previously mentioned, because the x and y components, they're both negative, that means that the vector lies in the third quadrant, since it goes down, since it's a negative y, and then it goes to the left, since it's a negative x value. So that allows us to know how much we need to adjust for the reference angle. So we'll just keep in mind that we know now that the vector P lies in the third quadrant. So to find the initial reference angle, we're going to go ahead and use the inverse tangent again. So I'm just going to set that up. So that's tangent -1. The y component, the absolute value, of course, of the component for y, and then the component over the x component for p. And then we just substitute in our values. So tan to the power of -1. And then, what did we put again for p? -31. And then that's over our x component of -61.53. Of course, these are the absolute values, so we just have to make sure we put that in there. Continuing on with this, we can just use our calculator to help us calculate it. So it'd be inverse tangent, where is it? And then we're going to put in our fraction. And then after inputting that into our calculator, we get 26.74 degrees. So that is our initial reference angle. But again, the question asks us to find the term in terms of an angle measured counterclockwise from the positive x-axis. So we need to add 180 degrees to that reference angle. So simply put, reference angle for P is equal to 180 degrees plus this reference angle of 26.74 degrees. Let's go ahead and add that up. Now we get 206.74 degrees. And then that's going to be our final answer for this part of the problem. And then finally, part M says, asks to state in which quadrant the angle P from part L lies. As I said, we noticed that both components x and y are negative. When both the components of x and y are negative, that means that it lies in the third quadrant. And this is proven by the reference angle that we found in the last problem. So we would put, for part M, angle P is in the third quadrant.